So in this problem, we're looking at graphing a simple quadratic. We're given f of x equals negative x squared. So if you remember from Algebra 1, we had transformations in which if you applied a certain aspect to an equation, it would shift it in a certain way. It would transform it in a certain way. If you remember, if you have a negative before f of x, that means that it's going to be a vertical reflection of the original f of x. So we have f of x equals negative x squared. That's just going to be f of x equals x squared upside down. We'll go ahead and plot some points. We know the general shape. We know it's going to be pointing down, and we know it's going to be the shape of a parabola. So with f of x equals negative x squared, let's look at negative 2, negative 1, 0, 1, and 2. So if x equals negative 2, then f of negative 2 equals negative 2 squared, which equals negative 4. F of negative 1 is going to be negative 1 squared, which is going to be negative 1. F of 0 is going to be 0, negative 0 squared is 0. 1, negative 1 squared is going to be negative 1. And then 2 squared is 4, so this is going to be negative 4. And so we'll plot those points. Let's go ahead and label our axes, x and y. We'll plot the points negative 2, negative 4, negative 1, negative 1, 0, 0, 1, negative 1, and 2, negative 4 to give us our general shape, and then we connect the dots and indicate in behavior with arrows, and that gives us the graph for f of x equals negative x squared. And again, later we'll look at transformations again. If you remember, this is the same thing as x squared, so if we had f of x equals x squared, it would be basically the same thing, but pointing up. So anytime we have a negative before the entire expression that's part of the function, it's just going to be a mirror reflection in the vertical direction.